Wait, what? Not supposed to show that part?
Yeah. I think Austin we'll be hearing from Austin afterwards.
I got my tax bit hat on.
Sweet. Okay, we're still just waiting for a few stragglers, I guess. 6:57. I've never actually worn my tax bit hat. I always feel
What?
a little bit self-conscious in these kinds of hats. The big build hats, it's like has an in-your-face feel to it.
Yeah.
They're cool though. It's a nice hat.
There's the Def Lambda macro right there above it. Okay.
All right, cool.
Yeah, I should have written a protocol for that nonsense right there. Anyway. All right. So should I host disabled attendee screen sharing? You're gonna have to.
Oh, I'm sorry.
Share my screen.
Okay, there we go. Now you should be able to.
Oops. Screen. All right, you seeing my slides?
Yep.
Awesome.
Okay, so usually we just do a go around and introduce ourselves. We actually have less people than I was expecting tonight, so that's both good and bad in that I was wondering how we were going to handle intros with everyone that we had. So, but now it's pretty easy. The direction is different for everybody, I think, what it shows you up top or on the list here. So I see myself and then Madison and Matthew and Sean and Nathan. Maybe we could just go in that order for intros. So I'll just quickly do mine. And Madison, maybe if you could go. So I'm Brian. I work at TaxBit along with Matt. He is my awesome colleague who agreed to do this tonight. So thank you, Matt. And yeah, that's basically me. I've been doing Clojure for about 2 years now. So really love it. Awesome language. Glad to be coding in it and glad to be part of the community here.
Hi, I'm Madison Griffin. I'm working for Tori Anderson, so BYU as a student web developer. I've been coding in Clojure for about 1.5 years now, and I think that's me.
Cool. Welcome.
Who's next? We can't remember that long.
Right, that's you, Matt. You're next.
Oh, I'm gonna go. I'll go last since it's.
Oh, okay, sure, that makes sense. How about Sean?
Okay, hi, I'm Sean. I'm from the West Coast, so this is kind of interesting for me to be able to attend a user group in Utah. I've been doing Clojure for a decade now in production, and I work at an online dating company. We've got about 100,000 lines of Clojure. So that's me.
Thank you so much for attending tonight, Sean. We really appreciate it. Nathan?
Yeah, so I'm Nathan Chatwin. I'm also a student developer at BYU working with Tori. I've been coding in Clojure for almost 6 months now. And yeah, I'll be graduating next April. So it's really cool to learn Clojure while I'm, still in school and things.
Very cool, right on. Thanks for making it tonight. We appreciate having you. Jacob? We're doing our intros, so.
Yeah, sorry, I came in a little late.
No worries.
I'm Jacob, one of the co-host organizer people for the meetup. I've been coding in Clojure for, since 2016. Did it for side projects, so now I'm doing it full-time as a startup founder. And I used to be in Provo. Right now I'm in Washington State. And that's me. And I like long walks on the beach.
And we had some other people join now, so my list is a little bit out of whack. So maybe whoever's not introduced themselves could go next.
I can go next. So my name is Yuri. I'm a student developer too. I'm doing Clojure it's been for 6 months. And yeah, I'm graduating, well, in a year and a half. So I have quite a bit, but I'm excited to be here today.
Awesome, thanks for coming. It looks like Luis is here. Oh, there he is. Here's Luis. Hey, Luis, welcome. Oh, you heard me. Hey, Luis, welcome.
Hi. Hi, Brian.
Hey, we're just doing intros in the startup, so maybe you could introduce yourself.
Okay. Well, I am Luis from Argentina, and perhaps this is my third time here in the meetup, and very interested in the subject today, the atomic ions. It is a great subject.
Cool, glad to have you.
Okay.
And then I will go ahead and introduce to everyone TaxBit, who is our virtual sponsor today. So TaxBit, and I'll introduce them from, well, first their business perspective, then the Clojure perspective. TaxBit is a company that handles the automation and mechanization of tax filing for cryptocurrency. And they're unique and interesting in that they have made a corporate commitment to Clojure. So they have a very extensive Clojure code base. Say 50% of the engineering staff are committed Clojurians. And they're hiring and have rapid expansion plans and are well funded, and I can attest it's a great company to work at. So. And with that, maybe Matt, you could also introduce yourself and maybe say something about TaxBit as well.
Sure. My name is Matthew Smith. This is the second time I've given this presentation. Brian asked me to give this presentation that I did for the Utah Clojure meetup, which we are trying to rebrand after COVID. So I've been working in Clojure. I've been getting paid to work in Clojure for about a year now. I've been working in Clojure for several years. I've got at least one Clojure Line-Again plugin out there that some people actually use. And yeah, so I've been working at TaxBit for about a year. We are heavy into Clojure and Datomic. And when I first gave this, we were just getting started with Datomic. We now have a year of actually using Datomic, and so I updated my slides a little bit to accommodate the lessons learned over the year. And so we've been successful with Datomic, and we look forward to being more successful in the future. So if anybody has any questions, just go ahead and stop me, or just interrupt, or say hey, or I guess you can't throw anything at me from this far, but yeah. And if I say anything wrong, patently wrong, go ahead and correct me, anybody who knows better, so that's fine too. All right, let's see. So yeah, so I think we'll just carry on.
Perfect.
All right, so here's the agenda. I'm going to talk about Datomic. Everybody kind of sound off of your experience with Datomic. Have you ever used it? And yeah, just kind of your experience. So everybody kind of like shake your head or say, yeah, I've used it, or?
Never used it.
All right.
I've used it. It's pretty awesome.
All right.
I have studied some from time to time, just in a theoretical point of view, but I don't have any experience in it.
Okay, cool.
I used it pretty heavily for about a year and then haven't used it since about January.
No. All right, maybe we'll ask you later what you decided to go with instead. All right, so I'm going to go over kind of what is Datomic, then we'll talk about Datalog, which is SQL-ish for Datomic. Then I'll talk about Datomic ions, and then I'll do a little bit of a demo, not live, and then I'll finish up with our lessons learned.
Perfect.
All right, what is Datomic? Datomic is I should edit this. New. Datomic's been around for several years now, so it's not really new anymore, but it's new to a lot of people, and the ideas behind it are still fairly new in the industry. So it's a distributed database, so that's not too surprising. It's transactional, and I'm going to talk more about what I mean by transactional in a future slide. It's also immutable or accretive. That means that you always add data to it. You never delete data. And that kind of is a little bit of a mind blower for those of us who are used to a relational database. Of course, you can query it. The query language is called Datalog, and we'll talk about that. And then it's super flexible while still being very usable. So carry on. All right, immutable. So data is never removed or replaced, but simply superseded. I keep wanting to spell superseded with a C, but the spell checker said it needs an S. But it still looks wrong to me. All right, so the idea is if you put a record into Datomic, and the record has a phone number, let's say, and then somebody goes in and they decide, hey, I'm going to change my phone number because I've got a new phone number. And then they say, oh, I'm going to change my phone number again. In most databases, you cannot figure out what the previous phone numbers were unless you go through a bunch of gyrations. With Datomic, just out of the box, I can query the history of a data element. So I could query what are all the phone numbers, what are all the different values that phone number has had over time, and when were they changed. So this, for Datomic, or not Datomic, for TaxBit, where we are doing taxes and we need an audit history, the Datomic is a beautiful database for us to use because we just automatically have an audit history of every element in our database. And so for financial and other sorts of applications that need an audit, this is a wonderful thing that just comes free with the Datomic because of the way it's built. This also makes testing a lot easier because you can't break anything. You can't change the database in a way that is going to break something. And as a matter of fact, they have ways to say, given the current state of the database, give me a virtual database and I can test using that virtual database. And at the end of the test, everything is just gone and the actual database just stays where it was. I come from an Oracle background and a MySQL background. So doing that sort of thing in those kind of databases, it takes a lot of preparation and months of discussions on how you're going to do it. Whereas with Datomic, it's literally just a call. Just give me the database, give me a virtual database, and I'll run my test. And then also, as you can imagine, backups are very simple. Because the database is immutable, I can just grab a backup at any point in time and I know that I will always have a consistent backup. With other relational and other databases where the data can change out from under you, you have to go through a lot of hoops to make sure that you have a backup that is consistent and hasn't been changed in the middle of the backup. I'm gonna go grab some water. I'll be right back. You guys can enjoy my next slide. Woohoo!
Maybe while Matt's gone, we can just, does anyone have any kind of war stories about using Datomic and like problems they've encountered or?
My main learning was, so in the documentation, especially if you're doing ions, they say, you know, ion, the cheap version ion dev is only for development. Don't try to use it in production. And my response was, challenge accepted, I'll do it anyway. And after about 6 months or so of that, I decided I had been thoroughly defeated, and yes, you should not try to actually use the development version in production because there's an enormous headache. But anyway, so that's my only war story. So.
All right, so is there any questions on that last slide?
No.
All right. So Datomic is transactional. Now, all databases are transactional. Again, when you write data to Oracle or MySQL, you create a transaction and you can commit and whatever. But the thing is that the transactions are ephemeral. Once the transaction's done, it's done, and you really can't go back and see, okay, what happened during this transaction? Datomic stores the transaction. So all the data that was updated during a transaction is all tied to a transaction ID. And you can then go back, and once you find some data, or once you find the data you're looking for, you can find the transaction that was associated with it, and then you can figure out what other data was there. And then, even more importantly, you can then attach metadata to a transaction. So you can actually, when you write a transaction, you write your data, but then you can also attach data to the transaction itself that's stored. And then so one thing that we're doing with that is we have an issue ID. So when our support people make a change to the database, they write out as part of the transaction the issue that was the justification for them making that change. So then when we go back and we look, hey, how did this data get changed? Oh, the support people did it as a result of this issue. Or we can go back and look for the issue and say, okay, this issue, what data was modified as a result of this issue? So again, these things are just out of the box, very simple to do. Whereas if I was trying to do that with Oracle, I'd have to create all sorts of stuff to make that happen. So is there any questions on that?
Matt, do we ever, or do people encounter problems where, you know, I guess the most intuitive, kind of obvious question or concern that someone would have coming from like a political background would be, hey, what if I store terabytes of data and now I can't delete it? Do people ever have those problems?
We have that problem right now, actually.
But where it's like, where they really, where they just have too much data and they can't get rid of it. And what?
Yeah. So a Datomic database has what they store data in what's called datums, which is basically a name value pair. And you can store about 10 billion name value pairs in a given database. Well, we're up over 1 billion already. And we have some pretty big customers that we're about to bring online. So yeah, we're going to be talking to Cognitect, the nice people who create Datomic. So basically what you have to do is, there's two ways to do it. There's a kind of an excise command But what they recommend is actually a procedure they call decanting, which is basically rerun all the transactions. Because you know all the transactions in your database, you can actually rerun them into another database, and then we'll just exclude the ones we want to get rid of. So we have a lot of, just for Brian's information, part of what TaxBit does is we provide tax forms for people, and the tax calculations are meant to be ephemeral, but we stored them in Datomic, and now their data is never going away. And so we need to get rid of all that old tax calculation stuff, and you know what I'm talking about.
Okay.
So anyway, that is one thing you need to consider is if you don't want your data to stay around forever, then you need to think about that as well. Because not all data is meant to stick around forever.
I have a quick question.
Yeah.
So are you familiar with the no history setting for Datomic?
We are now.
So I'm just wondering, like, going forward, is that something you would use for these calculation things, unless you were explicitly wanting to be able to query the history of those?
So yeah, that's one thing that we're doing. And then another thing we're doing is we are using we're actually using different data stores. So AWS has really this wonderful concept of, we have many, many different types of databases, just use the right one for the job. And so for storing all our transaction data that we need audit on, Datomic is the right tool for the job. For storing transitory tax data, tax calculations, Datomic may not be the right tool for the job, and so we're actually looking at tools for storing that data. And no history is going to be turned on. And I'll talk about that in the lessons then. Okay, Datomic is very flexible. So you can think of it's closer to a NoSQL database than a relational database, although it has its own characteristics that don't make it really a very good NoSQL database as well, or it doesn't fall into that classification. And so when you create a schema in Datomic, you define the data types, but you don't define the structure. And so from a relational point of view, you define the various columns, but you don't put them in tables. And so you define that a name is a string, and you define that a user ID is a UUID, and you define that birthday is a date, and so on. But you don't define a structure that says there's a person table that has all these things in it, but instead you just dynamically add data to an entity on the fly, and then just the content of the entity defines what it is. And I'll talk about some of the problems with that a little bit later, but for the most part, that works out really well, because then when we decide, so I worked at my previous job, they'd been in business for over a decade. And so they had this huge primary table that had all their data on it. And then they had all these other tables that joined to it, because you couldn't update that table without causing risk and problems, and so on and so forth. And with a Datomic database, you don't have to do that. If you want to add a new data type, you just add it and then start attaching it to entities, and everything works out just fine. Okay, Datalog. All right, so on the right is a SQL select. So we're going to select 3 columns, title, year, and genre from, we don't know what table, because Datomic doesn't have tables, so and then where title is not null and genre is not null and year equal 1985. So that's a very standard looking select statement from whatever database you're used to. That same select statement is the thing on the left in Datalog. So Datalog is the query language that's used by Datomic. And rather than doing a query, what it does is it tries to find matching patterns. It's more of a pattern matching, or even if you're familiar with logic programming, it's more of a logic programming approach to a database rather than a query. So there's the find, and then we're going to tell it which data we want. So title, year, and genre. The question marks at the beginning say these are data elements that need to be gathered from the database or from data passed in. So then we have our where clause. And so I'm going to skip the question mark e's for just a second. And so we have an attribute called movie title. And the value for that will be just an unknown value of title. And then we have movie release year, and that's the year. And then we have movie genre, and that's the genre. And then finally we have movie release year, and then the actual value, 1985. So what it does, so the E is kind of your primary key, or it's actually your entity ID, but you can think of it as a primary key. So what this query will do is it will go find all entities, or all entities with a release year of 1985. It will then see if that entity has a movie genre attribute. And if it does, it will fill in the question mark genre with what that value is. It will then check to see if the entity has a release year, and we already know it does because we specified 1985. So it'll put 1985 in the question mark year. And then it will see if it has a title, and if it does, it will fill in the title. And so then it will return the title, year, and genre. If any of those don't exist, then that won't be included in the return in the result set. So as Brian probably recognizes, is actually the where clause is in the wrong order. The release year 1985 should be the first thing, not the last thing, but that's okay. So this example of where we define the shape of our entity by the query that's looking for it. So if a movie doesn't happen to have a genre, then we're not going to find it in this query. And that's not because there's something external to this to saying all movies have to have a genre. Instead, it's movies can have a genre, and this query will find only movies that do have a genre or a title.
Does everything in the find key have to be in the where? So like you had find, title, year, and genre, and then you had the title, year, and genre also under the where. Is that normal?
If you're using the question marks, that is normal. That's very normal. So the things with question marks in them have to be defined either somewhere in the where clause, or I didn't do a more complex example where you can actually pass data into this thing as well. And so you can actually pass data in. So I could rewrite this so that we're passing in the release year instead of hard coding it, for example. But yeah, you do need to match the stuff in the find has to come from somewhere, and it's usually in the where clause. It's a good question.
Hey, let me jump in really quick. Brian, are you there? Because I don't know if everyone else sees it, but it looks like this meeting is hosted on a free account, so we've got it.
I am
Oh, okay.
putting in the.
Woohoo, yeah.
Okay, perfect.
Yeah.
Just want to make sure
Good.
we didn't all get cut off.
That's why I was silent for a minute. I thought we had done this already, but apparently we hadn't. So I'm glad you saw that too, Jacob. We're good. We can go the rest of the hour.
Sounds good.
Okay, awesome.
I have a question real quick. How dangerous is Datomic in the sense of how easy is it to accidentally write non-performant queries? How liable am I if I'm just tooling along writing a query? How liable am I to accidentally write something really that takes forever?
Actually, that I should have included in my lessons learned, and I didn't. So again, coming from an Oracle background, I'm used to having a query optimizer running, and so I don't really worry too much about, oh, hey, I'll group this thing and I'll join these and I'll do that, and the database will just take care of it as long as I've got the right indexes. Datomic does not have that. It does have an optimizer, but it is nowhere near as complex as like an Oracle optimizer. And so when they talk about writing performant queries, you do have to do things. Let me see if I can get back to that previous slide. Okay, so like I said, I wrote this query poorly, and how poorly is what the way the Datomic works is it will go through, and the way this query is written, and it will find every movie that has a title. So basically that's a table. From a relational database point of view, that's a table scan. So I just did a table scan. And then now I'm finding every movie that's got a release year. And so that's actually a join because now I've got this E at least. And then genre. So basically you can think of these first three lines as like a cross-join table scans, and the performance is awful. Now, if I put this first line, the last line first, where I'm saying the release year is 1985, now I'm not doing a table scan anymore. Now I'm doing an index scan on just the release of where the release year is 1985. So now I've cut, and so yeah, you have to write your queries in the order you want them executed.
Yeah. So one thing that Datomic says, like if they come and do consulting or contracting with you, is to write the most constraining term of your query first, closest to the where clause, and the least constraining, so like where employee last name starts with A, at the end.
Yeah,
right?
so,
And then because the filter from one is the input to the next one.
yeah, that's a good way to think about it. Is it's
So that's really how it runs under the hood. Okay, that makes sense.
yeah. And so we got bit by that multiple times until we really learned that lesson. Because it really is, you really can shoot yourself in the foot if you don't think about what you're doing, which is something that I really wasn't used to coming from a Oracle kind of a background where Oracle's really good about optimizing my queries. Okay. All right, so that's the Datomic. So now the Datomic has multiple implementations, and the Datomic we're using is Datomic Cloud. And so that's an AWS managed and hosted Datomic instance. If you're familiar with AWS, they give you cloud formation templates, and they're pretty simple to use, and you just deploy them, and then voila, you have a Datomic instance up and running. It is aggressively backed up. It's aggressively caching. They use all sorts of AWS things behind the scenes. They're using DynamoDB. They're using S3. They're using all sorts of things to ensure that you get the best performance out of your Datomic. It's worked out pretty well for us. So it's also very scalable. And so what they have is a primary compute group, which is one stack in a cloud formation. And that compute group is actually responsible for writing to the database, so transacting in the Datomic vernacular. And then you can have multiple query groups that are just for reading. So your queries execute on the query groups. And so we have 4 query groups set up. We have one for our web, so anybody who's using our website will be using the web query group. There's an analytics query group for doing, analytics kind of stuff. We have a support query group, so the support team and the developers can run nasty long-running queries and do the things that we need to do without impacting the web at all, because they're running on a completely separate instance. And then finally, we have a nightly sync that runs, and it runs on its own query group because it's got some pretty nasty requirements, because it's running a lot as quickly as possible. And so when we had that running on the same as the web, it would bring the web to a halt. But now, with it being on its own query group, we can, it does that and it doesn't impact anything. So the query groups themselves, each query group is scalable, and then you can set up multiple query groups with different types of access that will allow you to access your data in a way that they don't really impact each other. And then the last thing is that the Datomic Cloud uses the client library. So Datomic actually has 2 API libraries that you use. One's called the client, one's called the peer. The Datomic Cloud uses the client library, which is a bit counterintuitive when you first do it, because the peer library is actually the one that's supposed to be closer to the database. But in this case, they're using the client library, even though your code is running in the same data, in the same instances as the Datomic is. All right, so what is an ion? Or what are ions? So ions are a way of running Clojure on AWS with the Datomic Cloud. So you deploy you write your Clojure code, you deploy it using their find deploy scripts, and then your code is now running in the same instances that Datomic is running, and it's actually running in Datomic. And so there is no network latency between your code and the database. You're running in the same code space as the database itself. That took us a long time to trust, but we went through, and we have a huge filter where you can filter for this and that and the other. There's like 15 different data elements, say, you can filter on. And so rather than writing all these, first thing we did was write a bunch of dynamic queries that were really ugly to maintain. But then we tried it out, and it worked out really well, where we could just make almost a pipeline of queries and take the results of the one query and pass it through all the filters. So we just basically create a pipeline of filters and then just run the data through all those filters, each of those filters executing a Datomic query, but we're so close to the database and its caching is so aggressive that we're able to do that in a very performant sort of way. All right, so oh, I should put that bullet point on the Datomic Cloud. So the Datomic Cloud is really a simplified Datomic hosting and deployment environment. And then, oh, okay, I already said all this. So, oh yeah, so if you're familiar with stored procedures, which is code running on the Oracle database, the Datomic ions are Clojure code running within the Clojure database. And that's all I have to say about that. Okay, here is the unhelpful diagram they give you that explains it completely. So there you go. There's your ions, very clear in one. So I looked at this diagram many, many times, and now that I understand how it works, this diagram makes perfect sense. Trying to figure out how it works from this diagram is an exercise in frustration. So I'll talk about some parts of this diagram that in the rest of my slides here. All right, there is a tutorial. It's real easy to find. Just Google for ions tutorial, Datomic ions tutorial. If you're interested in ions, definitely go through that tutorial. There's a lot of new things to understand, and the tutorial goes through step by step and really got us up and running in a very short time. All right. So there's actually different types of ions. There's basically two types. There's a lambda ion and an HTTP direct ion. If I move my mouse, can you guys see it?
Yes, we can.
Oh.
Yeah.
So when you write a lambda ion, then that ion is just a lambda function like any other AWS lambda function. And so you can point events at it to run. You can link it through API gateway so that you can then have a web interface to your Datomic ions, and you can set that up. And then they have a thing called, which on the thing is called direct, but it's actually called HTTP direct. And this is one of the things that's confusing. It's actually pointed to a lambda. It doesn't actually go to a lambda. It goes to this proxy 2 thing. So when you write, so you can write 2 different types of ions. So the lambda ions, we started with the lambda ions because we were writing a web interface, and so having an API gateway and all of that worked out really well, except lambdas take a long time to start, and lambdas running Java take a really long time to start. And so we were getting timeouts, not because Datomic was slow, but because lambdas, I ran one this morning, and it took 30 seconds, 45 seconds for the lambda to fire up. And so we just could not have that sort of intermittent failure because a lambda hadn't started. And so we moved to we changed to the HTTP direct, and that even though the arrow points to a lambda, it doesn't actually use a lambda, it just calls your function directly. And so that's actually worked out really well for us.
Do you have comparison, Matt, on startup time for the HTTP direct versus the standard?
There's no startup time.
Oh, there was no startup time. So the 45 seconds was zeroed out effectively.
Yeah, it's gone.
Okay. That's interesting.
So that's not to say we aren't using lambdas. We are using some lambdas in different scenarios, but not for the web interface.
What was the degree of configuration or redevelopment or changes, if you will, that had to occur to go HTTP direct Do you have coded samples for that, for the one versus the other?
I could probably bring it up.
Okay.
So the HTTP direct, so with the web, with the API gateway, you can say for this call this lambda, for this call that lambda. HTTP direct doesn't do that. All calls to the HTTP direct go to the same function, and then you have to have your own like ring router or whatever to distinguish the code. So you remember we've got that router table that we use. Okay, so I'll show that when I get to the code part.
Okay.
All right, so this is a web ion from the tutorial. So ions get a map as the only argument, and it includes headers and body, and I'll show some other things that are in there. And so then what this code does is it expects a keyword in the body, so colon something. And so then it will read that. So the body will be a string, and then the read Eden is going to convert that into a keyword if it looks like a keyword. And so then if it really got converted to a keyword, we're going to then return, and you'll notice that the return has 3 elements: a status, a headers, and a body. The status is 200 for a normal return. Headers, we're going to add a content type, tell it that we're returning Eden. And then the body is going to be, we're going to return a string. So we're going to do a database query, get the connection. We're going to do the type. I haven't figured out how to make this thing go back a page. All right.
You just hit the left arrow. At least.
I tried that earlier and it wasn't working. Now it's working. All right. Thank you.
Yep.
All right. So we get the database, we get the connection to the database, and then we do a query based on the type that got passed in, and then PP string is a pretty printer, so it will return something that looks nice, a structured return. If the type isn't a keyword, then we're going to say a 400, which is a error, and we need the body to be a keyword, naming a type. All right, so this is the basics of both an ion or a web ion and an HTTP direct ion, where you're going to get some data passed in, and then you'll return a structured thing with status, headers, and body. And then if you want to get the database, then if you want to use the database, you can, but it's not actually a requirement of the ion. The ion can just return whatever. Now, the nice thing is that this then becomes a very testable thing, because there isn't really any database connection other than this get connection call, and that's just the same call wherever. And then d/db. I guess I should say, from a Oracle point of view, getting a connection to the database is a very expensive sort of thing. For a Datomic program, getting a connection to the database is almost a no-op. So it's just, it gets the first connection and then it memoizes it. And then every time you call get connection after that, you just get the same value back. So a connection isn't really a pipe to the database in the way that we think about it from a relational point of view. It's at a higher level than that. And so they can be reused. And so then the d/db is also a very quick thing to do. So a lot of times if you were looking at SQL code, you would pull this Git connection out because it's going to be a very time-consuming thing. In a Datomic, it's cached and it's just returned. All right, so there's this concept of ionization, which is to take that function, which really doesn't have anything to do with ions, just standard Clojure code. And then we're going to say, this is something we're going to export as an ion. And so then the other information that needs to be attached to that call can be attached to the call by Datomic. And so when you create a web ion, you'll create a nice just function that does what you want it to do, and then you'll ionize it, and that's the thing you actually expose. So here's an example of the arguments. So there's body and headers. There's also a protocol, which is HTTP1. There's the remote address, the request method, and on and on. You can find this in the documentation. And so, yeah, so you can get all the information you would normally get from some sort of HTTP listener.
Cool.
I'll bet I'm disappearing. It's getting dark.
I was gonna say when we first started, when I saw you were outside, this might be interesting. But
Yeah, I do have a light in the house, so maybe. All right, that's okay. You don't need to see my face.
If you're okay, we're okay, I think. So
I don't have to see me.
all right.
All right. So as part of ION's definition, there's a resource file. And so in the resource file, you tell it which lambdas you're going to expose. So not every Clojure function that is included in your file will be accessible from Clojure or from Datomic. So you have to expose the ones that you want. And so here's the items by type ionized, ledger item by type ionized. So that's that function we were just looking at. It's using the API gateway proxy and a really poor description, ionized version of items by type. All right. Then the other thing is the HTTP direct, and you tell it a handler function. And so in this case, we have a handler called HTTP direct in Ledger API Ion transaction. And so all calls to that ion get routed to that function, and then that function is responsible to route those calls as needed. All right, so once you write your code, you then commit your code to Git, and then you do a Clojure push, and then a Clojure, or Clojure push, and then a Clojure deploy. So push bundles up your code with all its dependencies. It's using the CLI tools as the dependency, not Linigan or boot, as the dependency manager. And so then it grabs all your dependencies and bundles them up into a jar file and pushes them up to S3. And then once that's done, then you do a deploy. You tell it the rev, and the revision is the Git commit ID. And so when you do this push, it saves it to an S3 bucket with that Git commit ID. And then the group is whether the compute group or the query groups that I discussed before. So you you can deploy different code to each of those query groups. So for example, on our support query group, we don't have the web code at all. We have support code that allows us to do the queries and whatever else we need to do for our standard support kind of stuff. And then you wait. It gives up after about 5 minutes. So if you're familiar with AWS, it uses code deploy and some step functions, and it's actually really well done, but it can take a long time. It is a hot deploy. So if you've got, say, 3 instances running in your query group, it will shut one of them down, leave the other 2 up, deploy to one of them, and then start failing over. So we do hot deploys in the middle of the day and haven't had any problem with it. If it fails, it just simply rolls back the old one automatically. So you're just in. So it's actually the deployment, well, it takes a long time, is very stable, and we've had a lot of good luck with it. All right, so I think let's see. Sharing is paused. Stop share.
So Matt, are you okay? Are you okay?
Yeah, I was just gonna try and bring up my editor because you wanted me to demo that a little bit.
Yeah, I think it'd be cool if you could show some code and show some working ion interactions and that kind of thing.
Sure.
People would be interested in that. And anything else that you guys can think of, maybe. I mean, I think Matt can.
All right, so we wrote a macro called def lambda, which is right here, and I'm not going to go through all of it. But the idea being that we wanted to cast an event whenever we called our lambda. We wanted to validate the inputs. We wanted to do exception handling and logging if there was an exception, and then deal with the responses in a sane sort of way, although that's ugly code, so don't look at that. And then here's an example of using that. So we define a lambda called adder name. And so we take an attribute ID and we want to convert it to its name. So it takes an input, and the input's going to be, so if you're familiar with Clojure schema, the input is defined by a schema. So it's going to have at least one element in it, adder, and it's going to be of type integer. And so if you pass it something else, it'll tell you, hey, I wanted something called adder. And then we just run a query, and you can see here's our find, here's our where, and then in allows me to pass attributes in. So I'm passing in the adder I got from input, and I'm passing in the database. And that's pretty much the same as theirs, just with a bunch of error handling and logging and metric generation and that kind of stuff.
Can you go through the def lambda macro one more time? Sorry, it might have been just me.
Well, I kind of didn't go through it. I just scrolled because it's an ugly macro.
So, are you able to make your font a little smaller, or?
Yeah, I guess. Well,
I mean, it might be good for some people to be able to see something like this. The def lambda
macro is a bad example. Don't do this.
They are actually fairly elegant in the sense that, it allows you to bypass a lot of code, and it allows you to centralize changes. So, like, let's say you maybe have 30 or 40 ions.
Yeah.
And, suddenly it's like, and even just that, it allows you to basically just capture just your business logic in one little place and the system logic in this macro. And so it's a fairly elegant design, I think. I mean, I'm not so experienced with lambdas. My only experience prior to this was at the cons last year. They had a pretty nice little set of classes that happened 2 days before the cons, where you can go there and you can do the Datomic class, and then you can do the ions class. But they didn't show anything like this, and so it's neat and kind of interesting. It's one of those war story kinds of things that even if you were to go and look on the blogs or look at other literatures, I don't know that you'll find this. So it's cool. I think it's really valuable for people to see this. I mean, so right here, this little body, squiggly at body, I believe that's going to be the piece, like that's what's, when you describe def lambda, that's that right there. And everything else in here is going to be replaced. This is kind of neat to see, I think, for people.
Yeah, he's talking about right here.
Yeah.
So if we look at this def lambda, this gets turned into at body.
Okay, cool. That is what that's doing then. And then were there any difficulties in developing this? Or, you know, I don't know that a lot of people write ions or write macros. I've never written a macro other than going through the textbooks, you know, and just doing it for fun.
Well, I guess you can kind of see the difficulties. So this return value here, we can get back all sorts of different things. So that was kind of over the course of time, we had to develop, you know, what can we send back and how do we deal with it?
Okay,
yeah,
interesting.
Yeah, that's yeah, I don't know. It's
yeah.
It's
What if
a
your
little
body
hard to read.
oh, sorry.
No, go ahead.
Well, I was just thinking, like, sometimes I've had, and this might just be, like, I've had lazy seeks come back where sometimes, so like here on line, I think it's 310, the do body again, like lazy seeks, sometimes I have to wrap them in a do all to get to force the execution.
Right.
But I know that that's also to do with, like, sort of the execution of the code, you know, the order of the execution. But do we ever run into problems like that? Like, I guess you could just pass the body, you could wrap the body or the def lambda, the code that's inside of that in a do all, and then effectively you have a try, a do all, and then whatever's in there.
Yeah, the idea here is that you don't, when you're writing the lambda, you don't see all of this, and actually you don't worry about it.
Okay.
You just have your code be self-contained, and if it needs to do a do all, it will do the do all.
Okay.
Or if it needs to return a seek, it can return the seek.
Okay, so this is actually going to define a lambda that gets pushed out to Amazon. Is that right? The AWS platform.
Yep.
And what is it doing basically? So you're running a query that's getting the attribute name.
Yeah.
In your, okay, it's just calling the DB ident. Got it. Okay, sorry, I'm catching up.
Yeah, so we can look up we have a lambda that will look up attributes by ID and return the name of it.
What's the minus CTX?
That's a bit of voodoo in the macro. So,
okay.
How do I explain it? Normally in a macro, you don't want to have any symbols leak out. And so that's why we have all these gen sims running around, because you don't want the symbols to be polluting your code. You don't want to accidentally overwrite in your code something that's defined within the macro. Okay. And this is a fairly complex macro, and there's a bunch of stuff getting defined.
Interesting.
And so, but there are three things I do want defined. I want to be able to get access to the original request that came in. I want to be able to get rid of access to our context. And then I want to be able to get access to the database connection. And
Now,
so,
what is the difference between a symbol and a keyword?
so a keyword has a colon at the beginning,
Okay.
right? So like colon context here is a keyword. Everything in here is a symbol, but that has to do with the way the macros work. So I define rec here, and then I reference it down here with the tilde. And so that will, whatever rec, anyway, I don't think I need to get in. This isn't a macro class, so we're kind of running out of time.
Okay,
So
sorry. I'm just trying to help extract a little bit of information that I feel might be valuable to people. So
yeah, I mean, so if I get optimistic, then this is what that macro expands to.
Did you evaluate it? How did you get from there to there?
Yeah, I evaluated the macro.
Oh, cool. Okay.
I expanded the macro without executing it. So this is the code that gets created that then gets executed. So
okay, sweet.
So there's our, anyway, so we're going to try, and there's the code that's doing the evaluation. Here's the code that's in that do. And then here's our exception handling. And then finally, we're going to return the right value. And if we get a throwable anywhere in there, then we're going to deal with that as well.
Cool. Okay.
Let's see, what else? Okay, and then here's our routes table. So like I said, the HTTP direct, you have to tell it what function to use or how to deal with them. So if the path comes in as /health and it's a get, then our handler is called health check. And so that's how the routes work. And it's very similar to the way ring works. If you've ever done any of that.
The standard routing table.
Yeah, we actually are using ring for a lot of it, not all of it though.
Okay. Which is nice. This is why it looks so familiar, I think.
Yeah.
Count ID, :ID.
Yeah.
Very nice.
Let's see. No, I think I'm going to get back to my slides.
Okay. Thank you, Matt, for showing us that code.
Okay. So lessons learned. I mentioned that Datomic Cloud uses the client API. So ions require you use the client API. Google search prefers peer. And so when you do a Google search for something, the peer and the client are very similar in the way they look. And so I have spent many hours trying to figure out why my code won't work, because I was looking at the peer API and not the client API. So when you are Googling for Datomic stuff, make sure you're looking at the right stuff, and the peer stuff isn't the right stuff. Another thing is that those of us who came from a relational world, we're very used to just going into the table and looking at the schema and seeing, oh, hey, what's in this table and what are the foreign keys, and just kind of being able to chase through the metadata of your data to reconstruct and understand how your data works. With Datomic, you don't really have that. There's no tables. There's just entities, and entities are defined on the fly. So it's real. You can't really define. Just go look at the data and really puzzle it out very well. So, as developers, you have to keep track of what your data looks like. So we are using a thing called Datomic Schema, but there's also Schema and Houdor that you can use to define your schema, so that then you can go look at it later and say, oh, this is what was intended. And we use that all the time. So that has worked out really well. So instead of just willy-nilly having some file, or even worse, multiple files defining your schema, we have a schema definition, and then we use that to create the Datomic schema, and then we can also reference it as we're coding. So definitely a lesson learned there. So AWS CloudWatch and other tools are your friends. So there's CloudWatch, there's Code Deploy, so in CloudWatch, there's dashboards, there's logs. You'll want to become familiar with all of that stuff and where Datomic writes all that stuff to really understand what's going on. Because it being a cloud thing, there's really not like logs to watch, so you have to watch in CloudWatch. Be careful with isComponent. isComponent allows you to say this entity is a child of some other entity. With the benefit in question mark of being able to, when you delete the one entity, it will delete all the children, but make sure that you're not sharing that child between entities. I spent many hours recovering from that. So just be careful when you use isComponent that you're not sharing the children. And then, yeah, I actually meant to write in a thing about no history, which will prevent Datomic from keeping old copies of stuff and save you some space. All right.
Cool.
I think my time is up and then some. But yeah, if you're interested in Clojure, and definitely go check out our website. We are hiring. And yeah, it's a good crew. So,
Cool. Thank you very much, Matt. We really appreciate it. Does anyone have any questions for Matt? I guess, Matt, the one question I have for you is, so I've also worked in tax before having come to TaxBit. And I know that for me, like back then I was a .NET guy, a C Sharper, a Link and Entity Framework and all that. And I guess my question is like, has tax pushed you to kind of come to know Clojure in different ways?
Definitely using it on a daily basis. So I've used it for my hobbies for a number of years now. It's kind of been my go-to for my not getting paid for work, and also for testing when I'm running in Java. It actually is a cool framework for testing.
Oh, interesting.
So yeah, I've definitely come to appreciate it more than I did. And I'm trying to think of maybe something I've learned over the last year, but nothing's coming to mind right now.
Yeah.
But yeah, definitely it's, and having some other people to talk to about it and is fun. So
Yeah. I mean, for me, so I was in sales and use tax, and like it really pushed the boundaries of. So in sales and use, right, their depreciation tables change every year, and they are constantly publishing new depreciation tables, and then you have to code those as rules. And so the company I was at had taken a the Fox Pro language in the database, and made that work from like 1984 until 2005 or six, which was consequently they had owned sales and use tax area, but they had gotten to the point where any change, any new code would just bring down the system and create defects that they couldn't get around. And so it's interesting in tax just because of it's like, here's stuff that the government came up with. Can our coding languages actually describe it? And sometimes the answer is no, at least not over time elegantly.
yeah,
And so that's kind of the root of my question is like, we really push the boundaries of Link and .NET, and something we kind of came up with then for that called knowledge-oriented programming, which was basically using so one thing I wanted to comment on, Datomic very much follows the RDF model of the memory model. So if you're ever looking for sources on like how to model my schema in Datomic, a place of inspiration that you can go is like RDF, or Resource Description Framework, from the W3C, and then the larger branch of knowledge or discipline, which is ontological engineering. And so it very much follows that discipline. And so it's kind of interesting that, I had applied that to tax, and it really pushes the envelope of these different frameworks. But ontological engineering is totally, it did not extend beyond the capabilities of that. So it's interesting, the challenges that come with tax on any language and or database platform. So it's cool to see Datomic also scale to that. And so my project right now with working with Matt is actually, we were in DynamoDB, and now we're bringing all that back to Datomic and putting our gain loss caching engine inside of Datomic. And that's been a neat project that Matt has mentored me on a little bit here and there when we've had time. And so it's quite interesting seeing Clojure and Datomic scale to the challenges that the IRS can throw at any language.
yeah, there are certain classes of problems that just disappear with Datomic and Clojure. There's other problems that then crop up, but that's always the way it is, isn't it? But so yeah, we've I think our implementation is much cleaner using Datomic for what we're using it for than I think anything else that we would have used to implement. Using Datomic and Clojure, we've been able to really write some nice clean code, and the database really matches what we want it to do, and we don't have to do a lot of fiddling of, oh, we got to do this, or oh, how are we going to back this thing up, or all those other things that kind of start muddying the waters of your code. And so our code really is much cleaner than I think it would have been otherwise.
Might have been, yeah.
I don't know, Brian, what do you think? Is it clean, or am I just
you're the different
one got thrown into it?
It's different. No, it's not bad. It's good code. It is good code. And like I said, I guess alluding to, I say that jokingly, but tax is quite complicated, and every language I've ever known that I've seen it in the context of tax problems, it looks a lot different suddenly than how you know the language to be. So no, I think our code is quite clean and quite capable and quite scalable. And you and Larry have done a terrific job in quite quickly, building a what we call the ledger, which is essentially an engine that calculates someone's financial activity, just like an accounting ledger. That is quite clean and quite well scaled and capable, and is nice and neatly described in Clojure. The one thing I'm not used to seeing so much in Clojure code bases that we've done a good job with, I guess, is the macros. So we have a lot more macros than I'm used to seeing. And that was one of the things at first that was jarring is not the right word. It was just kind of like, oh, wait, what is this? And how are we using these? And, you know, and then we're also using, I think is it called Kava, Matt, the rule engine? Which
Clara.
Clara, thank you.
Yeah.
It has its own set of macros. So when you put the two together, kind of our macros and the Clara macros, you see lots of macros. It's sort of like a bunch of macros got together and had baby macros almost, you know, they're just sort of, and it's really just that took a little bit of getting used to, but after that, it's like, okay, this is pretty sweet and it scales and it works quite well. So,
cool.
Yeah. So yeah, does anyone have anything else to add or throw in? Guess we should let Matt go. He's in the dark and probably cold as well.
And the mosquitoes are out.
And the mosquitoes are out. Okay, so
regarding your whole code base, how much of it resides in the ions, and how much resides outside of ions?
So all of the code is contained within the ions. But only a very few things are exposed to the ions. Does that make sense?
Okay. Do you feel comfortable with such an architecture?
Yeah, it's working out really well. The code so this code is meant to be a web service, and so having it exposed, having what we have exposed, and then the rest of it sitting so close to Datomic makes it run really fast. And then, like I said, deploying takes longer than I want it to, but it rolls back automatically. It's really a nice deployment. And so yeah, no, I wouldn't change it. Now we have other Clojure that was written that's just lambdas, and it really isn't talking to Datomic, and so that is not written as ions. It's actually just written as a plain lambda running Clojure. And again, it has ugly startup times, but there are ways around that. And but for the intent of what it was designed, that works out well.
And when you say lambdas, you mean they are finally implemented as AWS lambdas, right?
Correct.
Okay. But you mentioned that they were quite slow to get it loaded. Do you haven't been able to get rid of that delay in getting the lambdas loaded?
Yeah, so AWS, Amazon has recognized the problem, and so they've given a couple of ways to work around that problem. One of them is I forget what they call it. Anyway, they keep one instance always running, and they don't really charge you for it, or they charge you a lot less. And so then you don't have to have the startup time. It's very responsive. If you start scaling, then every time it starts up a new one, oh, my wife just turned off the light. Every time you start up a new one, you will have the startup time, but because those things are part of an event-driven architecture, and so there's nothing really waiting on it, so it's okay for us to have that delay.
Okay.
Okay, cool. Yeah, I think we should let Matt go. That's actually a good segue though, Matt. So next month we're gonna have Bobby Calderwood of, I forget his company's name now. I apologize to him for that. I think it's called Eventful or something like that. He will talk to us about eventful architectures, and it should be a really great talk. He has worked extensively with like the Joint Chiefs of Staff for the U.S. military and other organizations like that. I think like the intelligence community, and in building fully eventful architectures which have no persisted data state. And I think it'll be again on the 4th Tuesday of the month in October, I think it is. Yeah, or in September. So yeah, hopefully you guys can all make that, and I'll get it posted. I think it's already posted, but I'll get the link in it and everything else. And we'll get Matt's video up online tonight, along with the one from the last meetup, which I apologize for not having up already. So thank you guys very much for coming.
All right. Thanks, Brian, for organizing this, and Jacob.
Absolutely.
Thank you very much.
All right.
Excellent presentation.
Oh, thank you.
Yeah.
Thanks, everybody, for coming.
Okay, I hope you can get
Thanks
back
to you.
to your house okay.
Yeah, me too.
Need to use your phone as a flashlight.
Yeah.
Okay. See you guys.
Okay, bye-bye.
See you. Bye, thanks.